Hey guys, I'm Ryna and welcome to GRE Fridays. Today I'm going to talk about least common multiples and we're going to look at some problems that are really least common multiple problems in disguise. Let's have a look. Let's begin with the definition of least common multiple. When we have two or more numbers, the LCM is the smallest number that is a multiple of both numbers. For example, if we have 5 and 7, the least common multiple is just 5 times 7, 35. But what happens if the two numbers are composite numbers? Can we be sure that multiplying the two numbers together will get us the smallest possible multiple? Take the numbers 24 and 28. If we multiply them together, we get 672. But there's probably a smaller number that both 24 and 28 go into evenly. Here's where we need a method for finding the least common multiple. I remember learning that we make a list of multiples of each number until we find one that they share. For our current situation, this would look like our list 24. The first multiple of 24 is 24, 24 times 1, and for 28. So we see here that the first number that the two numbers have in common is 168, which is far smaller than 672. The problem with this method is that making a list takes time we do not have on the GRE. So we need a faster solution. And here's what we're going to do. We're going to start by finding the prime factorization of each number. So we draw a factor tree. 24, two numbers that go into 24, 2 times 12. 2 is a prime number, so we circle all the prime numbers. That's the end of that branch of the tree. Now we have the prime factorization of 24. If we wanted to, we could rewrite it like this. 24 equals 2 cubed times 3. Prime factorization. Let's do that for 28. Oops. All right, now we have our prime factorization of 28 is 2 squared times 7. So we're finding our least common multiple. We start by looking at every factor that the two numbers share. There's a 2 here and a 2 here. I'm going to write down 1, 2 to represent this pair of 2's. Next, I see a 2 here and a 2 here. I write down another 2 to represent this pair of 2's. At this point, this is all of the factors that they share. And now we have to include all the other factors that are unique to each number. So for 24, we have another 2 and a 3. And for 28, we have a 7. Now we've considered every single prime factor of both of these numbers. And we multiply it out. So we get 8 times 3 times 7, which is 168. This is the exact same number we got using that list method, but it's a lot quicker because if you can't do 24 times 5 or 24 times 6 quickly in your head, that's going to take a while. But we can easily get to the prime factorization and find the least common multiple that way. Now let's do a GRE problem that uses the least common multiple as the method of solving. This is going to be a word problem that doesn't look like what we just did. It kind of masks the fact that it's really a least common multiple question. So let's take a look and see how we know that it's a least common multiple question, and then look at how we would solve it. Our problem reads, in a certain medical group, Dr. S schedules appointments to begin 30 minutes apart, Dr. R schedules appointments to begin 25 minutes apart, and Dr. W schedules appointments to begin 50 minutes apart. All three schedule their first appointment to begin at 8 in the morning, which are followed by their successive appointments throughout the day without breaks. Other than at 8, at what times before 1:30 will all three doctors schedule their appointments to begin at the same time? We know that this is really a least common multiple question because we have different amounts of time for each doctor. And then we want to know which times of the day they will overlap. So if we find the least common multiple, what we're really finding is how many minutes does it take for their appointment schedule to sync up again. So every certain number of minutes, that least common multiple amount, they're going to have appointments that start at the same time. And we're going to figure out what that is and how often they're going to have appointments that overlap or begin at the same time and before 1:30 that day. Anytime you see a question like this, where there's 2 or 3 different times that things begin, it's really a least common multiple question on the GRE. So let's take a look at actually solving this. We're going to find the least common multiple of 3 numbers this time, 30, 25, and 50. Our first step, as always, is to do a prime factorization for each of these numbers. All right, so here are our factor trees for 30, 25, and 50. Now, when you're looking for the least common multiple of 3 numbers, it's the same method, but we only need to have a number shared amongst 2 of the numbers in order to count it just once, just like we did before. It doesn't have to be shared across all 3 numbers. So let's take a look at what first we always start with the numbers that they share in common. So there's a 5, and a 5. We can write 1 5 this time. And here's another 5 and another 5. We can write 1 5 there. Next, we see a 2 shared across. And then lastly, we have to include that 3. So the least common multiple here is 150. Let's remember what that means in the context of this problem. Because 30, 25, 50, these are all minutes, 150 is the number of minutes. So every 150 minutes, we're going to see that the doctors have another appointment that starts at the same time. So if we begin at 8 a.m., the next time that they have an appointment at the same time would be 2 hours and 30 minutes later. So that is 10:30 a.m. The next time that they would have an appointment at the same time, again, 2 hours and 30 minutes later at 1 p.m. And because the question wanted us to stop at 1:30, these are going to be the only 2 times that all 3 doctors have an appointment beginning at the same time on any given day. And that's how we solve that problem. So again, remember, anytime you see this sort of thing, it's pretty common on the GRE. It's always going to be a word problem, and the method for solving is always going to be using the least common multiple method. Thanks so much for watching. As always, if there's a specific question from the GRE that you'd like me to talk about, drop a comment and I will make a video talking about it. See you next week. Bye.